Hi, welcome to the fifth tutorial of the Xmgrace tutorials. So in this tutorial, I will talk about how to make a histogram using Xmgrace. So we'll have a data set and we're just going to open it up in Xmgrace and then transform that into a histogram. The reason I say we're going to do that is because we can't straight away plot a histogram when you open the data using Xmgrace. So let's just take a quick look at the data that we have. So it's just a series of numbers. Okay, so you have 3 ones and 6 fours, and there are 2 twos and 2 threes and about 13 sevens and 3 sixes and 1 5. So there's just a list of data that you have, and a lot of times when you have a measurement, for example, the heights of different students or something, you just note the height of each student or the weight of each student in a class maybe, and then all you have is like 50 different numbers in your data set, and you want to see a histogram between two intervals. What is the population, or what is the number you observe between a given interval of values? So that's what we're going to do using Xmgrace. We just have like a very simple data here. So we can just consider the interval to be a unit of 1, like 1 unit for like 1 to 2 or 2 to 3 and so on. So we can open this plot in 2 different ways, using the command line or using the GUI. I'd like to show how you can open this with the command line. So we're going to use the block format. So Xmgrace -block data.txt -bxy. So you want to plot the block as an xy. And what are the x and y columns? You only have one column in your data, right? So you're just going to plot the same value against the value against itself. So it'll be 1 to 1, like your x comes from column 1, y also comes from column 1, because you don't have any other columns. And there you go. Okay, so you have your data, 1 plotted against 1, 2 against 2, 3 against 3, and like each number is plotted against itself. Okay, but this is not what we want. We want a histogram. So in order to transform this this particular display of data into a histogram, you have to go to data, go to transformations, and go to histograms. Select that. Okay, this let me go over in a little detail about this. So it says Grace histograms. That's what you're trying to transform into. And you have a set here and you have another set here. If you look at these names, this is the source set and this is the destination set. So in order to transform this data without making any major, without messing up anything major, the safest way to do is right click on this set. Okay, select this first. I don't think it was selected before, and right click and select duplicate. So when you click duplicate, you see that the same set has been duplicated in both the source and the destination. Okay, so select the set in the destination, and the one, the selected set in the source, you're gonna right click there and click hide it. Okay, so you first duplicate your set, and whatever changes you want to do, you do it in the destination. That's what shows up at the end. Okay, you don't mess with the source, you mess with the destination. That's what we're gonna do. But if we like change this to show, you will see a line plot like this and a histogram on top of that, which is not ideal because the units will be different. It's no longer 1 plotted against 1, 2 plotted against 2, or you don't have an x comma x type of a coordinate in the histogram. So it'll be a mess, and you don't even want this representation. That doesn't mean anything. So, which is why we're gonna right click this and hide it. There's a reason. That's the reason for doing that. And what we're going to do next is we have to pick the start, stop, and the number of pins. Okay, so the start value is where you want your histogram to start. And the stop value is what is the last value that you see, like where it starts and where the value ends. Okay, and the number of bins is basically how many divisions you want to divide the histograms into. Okay, so I have numbers from 1 to 7, right? So I can start from 0 to 8. And if I want one bin for each number, I could divide all of that into 8 bins and click apply. And what you see here, what do you see here? So you see that you have like 0 to 7, and you have it divided into 8 bins. There's of course nothing there beyond 7, so you don't really see it here. So from this, you can see that 0 to 1 basically represents 1. So the number of ones you have in your data set is 3, right? Which is why it's a 3 here. You have 2 2s and 2 3s, and 1 to 2 represents 2, 2 to 3 represents 3. And the same way, you keep going until 6 to 7 represents 7. And you don't have to worry about what 7 to 8 represents because you don't have an 8 there. So it will be a 0. So if you want to stop at 7, we can try what happens. And that's perfectly fine. You just stop at 7 because that's what you, that's the biggest number you have anyway. Now, I would suggest for the start and stop values, if 1 is the lowest value, I would say pick the start at 0. And if 7 is the highest, pick the stop at 8. So my suggestion would be to have start and stop values such that the start value is 1 unit less than the lowest value in your data set, and the stop value is 1 unit higher than the largest value in your data set. Let's keep this here. This actually 7, the maximum 7 doesn't seem right because we know there are 13 7s in your data set. So let's go to Axis properties, okay? Let's just change it up to 8, just in case. And let's go to Y-axis and make it 14, okay? So now we see the entire plot, right? You see that happening here, okay? Now we can make it more presentable later on by changing the font size and so on. But for now, let's go to plot, set appearance. Okay, when you go to set appearance, the first thing you see is it's the G0S0, the data set that's hidden, that is being selected. So if you want to make any changes here, you'll be making the changes to a data set that is invisible. So you have to make sure to select the data set that you are interested in that is actually visible on the screen, which is G0S1. Okay, so once you have that, you go to line properties. Okay, look at the line properties. You see the type is left stairs. So what left stairs means is that you have data from 1 to 7. So 7 will be represented, if you have like bins of like 1 number per bin, then 7 will be, the number of 7s will be represented by the bin that goes from 6 to 7. Number of 6s will be represented by the bin that goes from 5 to 6. 5 represented by bin that goes from 4 to 5, and so on. And 2 will be represented by the bin that goes from 1 to 2, and 1 will be represented by the bin that goes from 0 to 1. So if you have left stairs, which is the default line properties type, you have to make sure that your start value is 1 unit less than the lowest value. If you start off with 1, okay, and then click apply, you see what happened there? Now 1 to 2 consists of the number of 1s and 2s. So that could be kind of confusing, right? Because like this, like every other bin only talks about the number of one particular value that you see, whereas this bin talks about the number of 1s as well as the number of 2s, which is not ideal. which is why I suggest making sure your start value is 1 unit lesser than the lowest value in the data in your data set, which here changes this. Okay, let's go to access properties, and I think that's there's something wrong with this here, I guess, but that's okay. Oh, sorry, I just said 0 to 7 and the number of bins were 6, so sorry about that. If you change it to 7, like now it's perfect. Okay, just make sure the number of bins are adjusted right. Okay, so let's explore what other options you have for the type of line properties. We don't need none, straight, segments, or 3 segments. We are interested in left stairs or right stairs. Click apply. What do you see? You see something changed, right? And what was that? You see that everything shifted. So when you represent your data as right stairs, the lowest value will go from 1 is represented by the bin that goes from 1 to 2 and not from 0 to 1. And 2 is represented by the bin that goes from 2 to 3. And so on, where 6 is represented by the bin that goes from 6 to 7. And 7 is represented by the bin that goes from 7 to 8. But hey, we don't see a bin here, and that's because we stopped at 7. Which is why I suggested that we stop at a value that is 1 unit higher than the highest value in your data set. And now click apply. It defaults to left stairs, so don't worry about it. Go to right stairs and click apply. And now you see your bin here. Okay, so whether you want to represent your data in terms of left stairs or right stairs is totally your call. I would just go with the default of left stairs, and that's just like, it's just your preference. I don't see how one thing is more advantageous than the other, honestly. So you can just pick whichever you want. And let's get back to the histogram field, and we can see that you have an option of normalize. I think you all know what cumulative histogram is, but we don't want to go to that now. If possible, I try to make a tutorial about that later. But for now, let's check out the normalize option. Click apply. You see what happened here? Like all of their y-axis values just went down. So let's just make the axis settings slightly bigger. Okay, 1 is still too much, apparently. Okay, so you have your axes reduced to, like it's less than 0.45. So what happened when you normalized? When you normalized, you're basically normalizing everything such that the sum adds up to 1. And what is the sum we are referring to? The sum I'm talking about is the 0.1 that you see here. 0.1 times 1 plus I don't know, maybe 0.06 or 0.65 times 2 plus so on, like whatever y value you see here times the number being represented in the bin. You compute the value for all the bins and you add all of those values and they will all sum up to 1. That's basically normalization. You make sure that the number of a particular value you have times the value. You take the product and you add up all of such products for all the different values you have. It has to add up to 1. Ideally, it wouldn't add up to 1, but you make sure it adds up to 1 by including or incorporating a normalization constant. And that is what Xmgrace does for you when you use the normalize option. So you're normalizing everything against a particular constant and it all adds up to 1. Okay, so normalization could be pretty useful, especially when you're comparing data across a wide range of studies. You just want to, there's no way to compare if your total number of, the total number of students you're inquiring about their heights or weights or whatever it is, if that's not the same across different sections in a school or across different schools, then obviously if you try to compare data, it will be biased. And in order to avoid that kind of a bias, we introduce normalization. And it's pretty useful in a lot of cases. So if you want to normalize, you just have to check this. I'm just going to keep it at this for now and just accept it. Okay, and so we have a normalized histogram here. Okay, and once we have a normalized histogram, we can just we basically have what we want to have, and let's just go ahead with making the plot look better. So we have this here. Now in the line properties, you want the line thickness to change. So style, we just want this, we don't want broken lines, and change the width to 3. Okay, so this is how your histogram looks when you change the width. Okay, now go to line. You're worried about line properties, so go to line. And in line properties, if you see, the draw drop lines option is checked. So uncheck it and apply. You see what happens, right? So if the draw drop lines is missing, you won't have the lines to distinguish the different bins. So if you don't want them, go ahead and uncheck it. But I would like to see the drop lines to distinguish the different bins. So I would make sure it remains checked. And if you want to color up your bins a little, then go to the fill properties, type, I would say, to baseline, and then check the color is blue. If you try as polygon, you won't see any difference here, but I think it makes a difference in some different types of plots, maybe. But I would just go for the baseline. You can just play with it and then see what works. Okay. And there you go. So you have colored your histogram. Okay. So once you've done this, let's just quickly go over changing the other axes. So let's go to plot, axis settings. So one trick I'm going to tell you here is when you have the spacing is 0.05 and you start from 0 to 0.45, you see that, like values like 0.05 or 0.1525 and so on, they have 2 decimal digits. Whereas 0.4, 0.3, they don't look like 0.40, 0.30, or 0.20, or 0.10, or 0.00 for that matter, right? So we want to make sure this looks more aligned, like the number of decimal digits are the same for all of the y-axis values. So what you're going to do is go to tick properties, okay? The major spacing is perfect. We don't need to change that. Go to format. It says general, okay? We don't want general. Go to decimal and change the precision to 2 and click apply. So when you format it to be a decimal, it's going to be a decimal. And when you say the precision is 2, it knows that you should have 2 decimal digits. And if it has only 1 decimal digit and the second is 0, Xmgrace will make sure to put in a 0 there. So you have all the Y tick labels aligned in the same way with the same number of decimal digits. So this is something you can play with. So you can also have exponential or scientific notations, or there are different types of notations that you can have here. Okay, but yeah. So then let's just quickly go through the routine settings. Helvetica bold and Helvetica bold. For a detailed tutorial, please refer to tutorial 2, and axis labels is 150, always, that's ideal. I'm sorry. And if you want to label your axis, what are you going to say? I would just call it normalized counts, whatever the counts refer to, and that's fine. Now go to x-axis. X-axis could be, you just have values of 1 to 7. So 1, 2, 3, or 7 could be just some data values, I just call it that. So if you're looking at a histogram of maybe the distances you measure in a particular molecule, or the angles you measure in a set of different molecules, you can just type that angle, so on, or distance in so and so units, and that's totally fine. Now that you have entered the label, you can just go ahead with Helvetica bold, because I don't see anything you can format here for the decimals or anything like that. That seems fine. So let's just change all the line width to 3. Click accept. So yes, we've dealt with the axis. Now go to plot, graph appearance, go to frame, accept. Okay, so you've done everything here. It looks perfect. Let's just clear out the white spaces. Go to edit, arrange graphs. Or if you want, we could also try this. Go to plot, graph appearance. I haven't shown this before, probably in this context, I guess. 0.14, yes, you can change it here too. 0.13 is a little too much, maybe 135. How about 137? Or maybe 14. I'd go with maybe 138, or even 135 is fine, honestly. It's perfect. Nothing's being cut on this side. And X max, you can probably have, sorry, 1.9. Okay, that's a little too much, so 1.6. Still too much, 5.5, maybe 5. You just have to play with these numbers. 1.3 is a little too much, so maybe go for 2.7. Okay, we're there. 2.8. So yeah, you just have to play with these numbers here, and Y minimum could be 0.1 or maybe 0.9. Okay, that seems perfect. And Y max, okay, 1 is a little too much, so 0.9, 9.6 maybe, or 9.8. Okay, perfect. Now click accept. So you can make these changes either in the arrange graphs or in plot, graph appearance, under viewport. You can either change it here or in arrange graphs. So pick one, whichever you find convenient, and do that. And we've cleared the white spaces. And here we have a normalized histogram. So let's not forget to save it. We can just call it normalized histogram.agr. Click OK. And if you want to save it as a PDF, which you would, I think, appreciate if you want to make a PowerPoint presentation or anything else like that. So go to custom. I prefer to do it this way, like the publication standard of 3.3 inch wide. Click accept and print. Close it. So you have the AGR, you have the PDF. Here you go. So this is your histogram. And this is how you make a normalized histogram in Xmgrace. And if you don't want to make a normalized histogram, you just have to uncheck the normalize option and you will get a simple histogram in Xmgrace. I hope you enjoyed this tutorial, and I will be making even more tutorials and uploading them to the channel. Until then, please go through the other tutorials, and if you have any questions about this tutorial or the others, or in general about plotting in Xmgrace, please feel free to ask them in the comments. I'll take a look at them and try to explain them over the comments, or even make another tutorial, make a separate tutorial to address the questions.